Hello guys, welcome to this new session. In today's videos we will continue developing our end language, and in the last session we develop and change our approach in compiling the source code by assuming that all code is a function, and we develop the call frames. So in today's session we will continue and adding the functionality of functions and its call. So let's see this simple code. We are in the top level code, the script, and we have print2, and we have some definition of a function, print 100. We declare a local variable and we assign it 100, and then we print that. After that, in the top level code, we call the function, and well, how do we know that it's a call of function? Because we have these two parentheses, so that means we have to call this print 100 function. So in the perspective of the bytecode, we have opconst2 and opprint for the instruction print2, and also we need to load the object, the function object, to the stack. So this is the function object, print 100 is the name of the function, and then we define it as global because this function is declared in the global scope of the top level code. Top level code description. And then what we need to do is to define that object with that name. And this is, guys, remember you on how we treat variables is the same way. We load the value in the stack and we define it with its name. So function is like variables. We call it, we check the hash table, and we get the object function, so we can call it later. So then we have a call, and what we need to do is to get global, and what's the name of that global variable is print 100. So then we have a new instruction called opcall. This instruction let the VM knows that the value on the stack is a callable object. So the next byte, it's a byte that represent the argument count. So in this example we don't have any arguments, so the value must be 0. And the function object, its bytecode is like this. So we have a local variable of const 100, and then we get that local variable 1, and then we print it, and then we return, we load nil to the stack, and we return because this function doesn't return anything. But by default our language, each function return some value. So let's see the state of the stack. So when we call the function print 100, we have the local variable 100, and let's assume that our IP is on nil, so we have the nil value, and then what we have, the VM will read the bytecode of return, and what will be the state of the stack is as so. We have the script object, the function of the top level code, and directly we pop that value and put it at the position of the object function that we called. So this nil will get the place of its function, and that's it. So we have this bytecode that we will implement, and also we will add some functions that compile the function, and it will return a object function to the VM. So let's jump to the code and see how we will implement that. So let's go to our compiler and let's go to compile function, and let's update our grammar. So we have function declaration. So what I need to do is to add that here, func declaration, and the func declaration is the keyword func and some function called function, and that function, and the function is just an identifier, the name of function, and left paren and list of parameters, and could be optional. You could define a function without any parameter. And we also have a closing paren and a non-terminal block. The block is treated by this one. So far so good. So let's define the parameters. So parameters will be identifier and a comma and another identifier, and that 0 or as many as time you want. So let's go to call. So let's update our unary non-terminal. So we have unary and primary, and what we will do is to call, and call is just a primary and a left paren and arguments and closing paren, and that also is optional for the argument, and for the whole thing is also, it could be 0 or many times as you want. Okay, so for arguments, what we need to do, arguments, it's just like parameters. So arguments, it's an expression. Arguments is an expression, comma, or another, or a lot of expression. So let's go and define that in declaration. We have statement. So what I need to do is else if match token func, we will call the function func declaration. So let's define that before the function statement, and here I will do static void func declaration, function declaration, and we will pass that variable, and if it is not a name, I will raise an error called expect function name. And if it is on a global scope, so it will return a value global, so we will define it later. So I will mark initialized, then also I will call a function and I will pass its type of the script is a function. So, and then I will define the variable. So as I said, variables are like functions. Functions are like treated as like variables. Global. So if it is on a global scope, this variable global will help us define that variable. Okay. So let's implement the function, called function, and function type, and let's do parsing here. So first of all, I will declare a new compiler so it can treat the bytecode of the function. So I will init that compiler, and I will pass the type, and I will begin scope. Why I did that? Because remember guys, when I do init compiler, so the scope is 0, and I don't want the variables inside the function be global. So every variable inside the function must be local. So I begin the scope. So let's start and consume the left parent, and I raise an error, expect after function A. So that's it, and here I will, in this session, I will not treat the arguments or parameters, so I will do some comment here. Compiler, compile the parameter list. So I skip that for now. So I will directly consume token right parent, and if it is not a right parent, I will say expect after parameters. So here we will treat the function body. So I will consume token left brace, and I will, if it is not a left brace, I will set expect left brace before function body, and I will call the block function, and it will treat its block. After the block finish execution, so I will end the compiler to get the result function. And compiler, remember our end compiler function, it returns the function object of the current compiler, and our current compiler is that compiler. So okay, then I will emit 2 bytes. The first one is up constant, and the second is I will make constant from object val function. So I turn this object function into some value, and I get its constant value, and then I will emit these 2 bytes. So far so good. So let's test that and see. Make clean equal. So we have an error here. Okay. Then compiler, let's see. All right. Okay, let's go to declaration function here, and I will add okay. So let's do it one more time. Okay, so far all is good. So what I will do is I will create a simple example, and I will do print2 and function declaration print 100, and I will declare a local variable var x equal 100, and then I will print this value x. So let's see, and sample and so as you see, guys, I have the definition, the bytecode of the function print 100. As you see, and let's print that sample. So I have opconst and pretrue for the first instruction, and for the others it's opconst2 as an object fn print 100, and I define it as a global with that name, and I will return it and return. So for the definition of the function is this bytecode. I will load 100 to stack, so it's a local variable, so I will get that local and I will print it. So far so good. So let's go and implement the call of the function. So I will go to chunk.h, and I will add the new bytecode up call, and let's go to our compiler to treat that. So let's go before function, and I will add a function called call, and bool can assign. So I will emit bytes of call with arg count, and for now I will initialize that arg count with 0 because I don't will treat argument in next lessons. So that's it, and let's go to our rules, and in left paren I will add the function call, the handler, and precedence, it has a precedence of call. So let's add the function here, static void call, and bool can assign. So far so good. So guys, as you see here, we have a call. So the parser, it will read print 100. It will say that it's a variable, so it will get that from the global, from our hash table. It will get that, and as you see here, it gets global that. And when I see a left paren, we will call our handler that emit the opcall bytecode. So let's go and debug that, this new bytecode. Let's see, and I will add case opcall, and what I will do is return, byte, excuse me. So let's add opcall, and what I will return return byte instruction up call, and I will pass the chunk and the offset. So far so good. So let's go to our VM to implement that bytecode and how the VM will treat that bytecode. So let's clear that and let's go to VM. Let's see. So I will go here and add that bytecode. Case up call, and what I will do is to get the arg count read byte. So I will implement that function later called value, and I will get the arg count, a peak arg count, and I will pass the number of arguments, and if it is false I will return interpret runtime error, and I will explain that now. I will update the frame to be address VM frames the last frame, and I will break. So this function, what it does, it will update the next frame, and then here in the code I will update the frame. It will be the next frame. And why I did that peak arg count, so I will back to the code. So we have no arg count, no argument, so the argument is not on the stack. So when I do peak arg count, so I will peak the object function. Focus guys, because when I do peak arg count, that's mean that the function is loaded on stack. So let's see that. Let's get an example. So if we have on the stack some function, so let's say a function, and I have 2 arguments. So let's say that function, it has the first argument 2 and the second argument the value 3. And the bytecode is up call 2. So what I need to do, our top stack is here. So what I did is to peak the number of argument count. So when I do peak 2, so that's mean I will get to get our pointer to offsetted by 2. So 1 and 2, then I will get the object function. So let's remove that. So let's implement that call value function. So here I will add that function here, static bool call value and the argument count. So if that value is object, I will call it. Otherwise, what I will do is runtime error can only call functions and classes, and I will return false. So I will do a switch case on object type value. If the type is object function, what I will do is return call as function, and I will cast that value into a function object, and I will pass also the arc count. So let's implement that call function. Static ball call, and it accepts an object function and the argument count. Why I pass that argument count? To return an error if the arity of a function is different than argument count. So let's say that this function, it has, at the definition, it has two parameters, but the user called the function with one argument. So that is an error, because the arity of the definition function is not like the argument count. So I will go here and test that. If the function arity different than arc count, what I will do is runtime error expect arguments, and got that, and I will print the arity number and arc count. And I will return false. So if the VM frame count is equal to frame max, that means we reach the max of our possible frames. So I will return a runtime error stack overflow, and I will return false. Otherwise, I will update the next frame. I will get it frame vm dot frame count, and I will post increment that, and frame the function will be function, and frame the IP is function shank.code, and also the frame slots is VM the top of the stack, and minus the arc count -1. So I did that because I want the slot pointing to the place where the object function is. So I did VM top stack minus argument count, because it could be many arguments. So I will subtract that from the top of this from the top of stack, the pointer on the top of the stack, and also I will -1 to get the exact position of the object function. So far so good. So let's see, and let's test that and see what will happen. Make main and make all. So okay, frames. Okay, vim, let's see. So everything is good. So let's go to our sample end, and let's add the call. So print 100. So what we have, okay, So I have an error, so let's go to compiler.c, and the error is on the call function. So when we have a call function, I need to test the write parent, the closing of the call. So what I need to do is to call a function called argument list. So for now, I will not read the count of the argument list, so I will do it will return the count of it, argument list, and what I will do is initialize that arg count to be 0, and I will return that arg count later. So here I will consume token write parent, and if it is not, I will raise an error. Expect write parent after arguments. So that's it. So let's see. So as you see, I have the bytecode. So as you see, I have opcall, and the number of argument is 0. And okay, so the issue here in the runtime, because I didn't treat the yes, okay, what's that? So I will go to vm.c and see the opcall. So let's go to call function. Okay, here I need to return true. So let's come back and recompile that. Let's execute that. So as you see here, we have opcall, so I will search for opcall at execution. So I will call this function object. So what we have, so now from after that we are on the print function, print 100 function. So as you see, I have opconst 100, I load 100, so I get the local one also that, so then I will print. So here the function is called. So the layer issue is here is when I load nil, I don't have, when I have the VM read the return, it finish the execution, so that it's false. What I need to do is to update the top stack to be here, and to continue on the top level code to be executed. So after the return of the function, I need to continue executing the rest of the script. So let's go to the VM, and in up return I will update that. So what will be is it will be, I will get the return value, the value on the stack, on the top of the stack. So I'll pick that, and I will decrement the frame count, and also I will check if the frame count is 0. That means we are on the top level code, the script function object. So I will pop the value, and I will return, I will finish execution, interpret success. So after that, if it is not, if we are on a function, I will update the top stack to be the frame slots. So the top of stack, it will point at the previous position of the function object, and then I will push to the stack the return value. And I will update the frame to be vm frames vm dot frame count -1, and then I will break, and that's it for return. Here I will not pick, I will pop the value to get directly the value from the top of the stack. So if the VM execute the return bytecode of any function except this, the function script, it will get the top value on the stack, and then it will return it on the previous frame. In our case, the previous frame is the script. So let's come back and re-execute that. Make clean and make all. So sample int, and I will do sample int. So as you see, the call start from here. Okay, and I print the value 100, and then I load to stack nil, and then this is the return of the function, this return, and I get that value, I pop it, and I push it on the position of the function object, the previous function object, and then I continue the rest of the code. So let's update that one, and also I will continue on the script here, but to see that the frame is continue executing. So as you see here, this is at the top level code of our code. So here the function, it finished its execution after the call, and after that the VM continue executing the rest of the code. So far so good. So guys, we reached our objectives. So the thing that in this session we implement the definition of function and its call, and how the VM treat that. So that is good. So our end language is capable now to declare function and call it. The next session, guys, I will treat arguments and the parameters. So bear with me. And the little thing before I will end this video, the little thing I will need to update in end language is that we have a bug in our REPL mode, the read, evaluate, print loop. So let's run the end interpreter without any file. So as you see, var x, let's declare a variable var x equal 2. So then I will print that variable. As you see, guys, I have a message error that says undefined variable. So the issue, guys, is on the function interpret. So what I need to do is to remove init from here and free VM, because at because at each execution of a line, the interpret it will run and it will init the VM and end the VM, so that is not good. So I will go to entry point of our interpreter, and here I will add in the main function, I will add init VM, and here I will end the VM, free VM. Okay, to update something in here, I will take the interpret result that the interpret function return, and I will call it result. So if that result is interpret compile time error, I will exit with that code 70 or 65, and if result equal interpret error, I will exit by 70. That is useful when we run the interpreter. If we have an error, the interpreter will return an exit code, and by doing some bash command you will get the code, and then we'll check what's the code is meaning, what's the meaning of the code. And also I will return here not exit 1 but 75. You can choose any number. Also at exit error I will just return excuse me, '74. Here I will return 64, and that's it. So let's make clean, make all, and see what is happening. And so far x equal 100, and I will print that one. So far so good. So let's see guys, if I did a compilation error, I didn't do a semicolon, our interpreter should return an error. So let's see on that sample end. So as you see, I have error at line 11 with that message. So let's do a bash script echo $, and you see that the code is 65, and the 65 code on the entry point of end is on compile time error. So that's useful guys. So one more thing I need to add is at the hash table I need a way to free the hash table. So I will go to table.h, and I will add that void free table, and I will pass that. So let's implement it in table.c, and let's go here after init table, and I will free it, free table. Why is that? Because when I free the VM, I need to free the tables global and string table. What we need to do is to call macro free array on entry and table entries, and I will init the table. So let's go to vm.c and on free VM I need to free the toTable free table VM.globals and free table VM.strings. So let's remake that. So far so good. VM.a, so I have, okay, that's good. So what we did is to free these two hash tables when the VM is at the time to be freed. So let's go to object.c and also at memory.c, and I will free also the object function is object function object, and I will free its chunk object function chunk, and I will free that object, and I will break. So let's clear all, clean all. So that's good. That's good. So let's rerun that example and see if everything is good. So guys, everything is good. We print 2 and we print 100 after in the call of the function. So guys, our VM is capable now for treating function and calls. So bear with me guys at next session to implement arguments, how to treat arguments, how to bind argument to functions, and how to treat parameters. So see you guys.